Hey Algebra! Let's talk about the Wednesday section of this week's assignment. If you haven't completed the Monday section already, I would definitely start there and watch the video and fill in this chart that compares linear functions and exponential functions. Yesterday in our Zoom meeting, we talked about what are exponential functions and we practiced writing some. If you missed that, the PowerPoint is on Teams. And for today, there are practice problems for you to work to practice with that equation. So let's review what that equation is and how to apply it by working the first two problems. So the equation for exponential functions is f of x equals a b to the x power. F of x is our answer, the function of x. A is going to equal our starting value. And b is going to equal our rate of change. And x is time. The unit for time can vary based on the unit you start with. It's usually years for these problems. So let's work number 9. The first year of the charity walk had an attendance of 500. The attendance increases 5% each year. Write the exponential function to represent the situation. So our starting value is going to be 500. F of x equals 500. And then our b value, the rate of change, is increases by 5%. So that's going to be 1 plus 5%. Another way to write 5% would be 0.05. So let me actually erase it and write it as 0.05 because that'll make it easier to add. Remember, if you're not sure how to find the percent, take that and divide by 100. So 1 plus 0.05. And then x is going to be our variable, so we leave that. So to simplify my equation, my final equation is going to be f of x equals 500 times 1.05x. If you prefer to use t for time, you're welcome to replace the x variable with the t. All right, so part B of this problem asks how many people would attend in the 10th year? Round your answers to the nearest person. So we're going to take this equation and we are going to plug 10 in for x. So f of x equals 500 times 1.05 to the 10th. Let me pull up a calculator. And I always start by doing my exponent and my parentheses. So 1.05, this x to the y button will give you the power. We want this to the 10th power. And then times 500. So that gives us 814.447, but since the answer is how many people, we're going to need a whole number of people. So the answer is going to be 814 people. All right, let's also work number 10. The population of a small town was 3,600 in 2005. The population increases by 4% annually. Part A says write the exponential function that represents the situation. So we're going to find the variables in the problem and plug them into our equation. So f of x equals a is our starting value. So this is going to be 3,600 times b, which is increasing by 4%. So 1 plus 0.04, and that is to the exponent that represents time. We can simplify our parentheses, so I'm going to rewrite and simplify. So this equals 3,600 times 1.04x. And that's going to be our answer for part A. F of x equals 3,600 times 1.04 to the x. What will the population be in 2025? Well, our first year was 2005. In 2025, that's going to be 20 years later. So 20 is going to be our x value. So I'll rewrite my equation and plug in 20 for x and then solve it. F of x equals 3,600 times 1.04 to the 20th. All right, so let's plug that into a calculator. Clear. So I do the second part, parentheses and exponent first. So 1.04 to the 20th times 3,600. That gives me 7,888 people. You have to round to the nearest whole number because you can't have a fraction of a person. So in 20 years, the population should be 7,888 people. So the first half of these problems are increasing, the second half of them are decreasing. So remember, if it's decreasing so if this problem was decreasing by 4%, instead of adding 0.04 to 1, we would have subtracted, because it's 4% less than 1. 1 is the number where the rate does not change. Everything stays the same. As usual, if you have any questions or just want to work them with me, come to office hours. Or if you get stuck, send me an email and I'll send you an answer helping you try to get unstuck. Where is that?